let's see how we did here. Okay, two other names for line AB. Well, probably the easiest, most generic thing to start with. Let's just flip it to BA. I haven't even looked at the picture. I probably should look at the picture now. Okay, AB. Well, the only other thing on the line is H. So I have to write the word line, and then I can use that little lowercase h. How'd we do? Crushed it? Maybe, I hope. Okay. Name a point not on plane F. Give me a point not on plane F. You got actually a couple. C or D. You pick. I heard C first. You could also have D. All right, next up. Name a pair of opposite rays. I'm going to give you one of them. You give me the other half. Ray BC. What's its opposite ray? BD. Has to start with the B. That's the only pair of opposite rays up there. All right, name a point not on plane A, B, C. Now, we talked about this yesterday. It seems weird. A, B, C. Through any 3 points, you can make a plane. So I'm not going to draw, and nobody needs to see my drawing skills. I could draw a plane around those. You got a couple choices here. What points would not be on that plane? E or D. Pick. I don't care. I heard E first. Last but not least, name a line that intersects plane F in exactly 1 point. Line G. Remember, the little dashed lines means it's going through the plane. That's the one that's intersecting it. Now, you could also call this line CB, line CD, a lot of different, any of those 2 points you could have used on that. Okay, let's go back now to the very beginning and do our algebra review. I just want to do the naming stuff that was fresh in your mind. Let's do these in a random order. Why not? Easiest one up here is 3. Let's do 3. Can you, I can't believe I'm going to say this, can you do number 3 with no work? X equals 2 and 4. I don't need any work on that, but just if you want to know, if you're like, how'd they get that? Remember, you just set each factor to 0 when you solve. All right, let's do 2. How are we going to factor 2? First thing you always look for when you factor, it starts with a G. Greatest common factor. What's in common in both of these? X. So X is our greatest common factor. You figure out what goes in the parentheses. What are you going to have to multiply that through 2? X minus 2. You got it. And we'll have x squared minus 2x. Okay, now we'll go to the tough one. Now, I can't factor it like we did yesterday. What multiplies to negative 15 and adds to negative 7? I mean, there's not anything, first off. Also, this is ruining our life. Yesterday, all the lead coefficients were 1. Different process. So lots of ways, lots of methods, I should say, to factor these problems. I don't care how you do it. Here's how I do it. I think most all the factoring methods start with this. You got to multiply 2 and negative 15 together. Now I'm going to figure out what multiplies to negative 30 and adds to negative 7. Multiply to negative 30, add to negative 7. What do you got? Negative 10 and... Now don't write this, because I'm going to cross this right off. Okay, this like causes me anxiety to write this. You can't just go, okay, it's x minus 10, x plus 3. Because if I distribute this out, will you get that back? Okay, that's why I said don't write it. I can't even look at that. So here's the problem. 2 is the problem, that lead coefficient of 2. So we have to adjust or scale these each by 2. You have to divide them by that lead coefficient. So I can mental math that, 10 over 2, 5, so negative 5. So my first factor, a minus 5. Now, 3 over 2, of course, doesn't divide out, so it doesn't reduce either. The bottom number, the denominator, goes first. in front of the variable, and then the numerator. And you can see if you distribute this, you have 2a squared, 3a minus 15a, there we go, minus 15. Got it. So there's other ways to factor it besides what I showed you. So if you have a different method you like, I don't care, you can use it. All right, let's actually get into geometry today, shall we? So it looks like a fancy title here, but it really isn't going to be bad. Measuring and constructing segments. Now, when we say measuring, don't worry, I kind of chuckle. You don't have to have a ruler or anything like that. You'll see there's some problems today with a little ruler underneath and you estimate how long it is. That's not very hard. We're also going to be a course when it says constructing line segments. You plot points on a graph grid and we're going to draw a line segment. That's what we're talking about. The big thing is this guy. We are going to use segment addition postulate. Now, that's just what it sounds like. Segment addition. You're adding segments. That's as wild as it's going to get, okay? So, let's start off, of course, with some more vocabulary because we can't get away from vocabulary in here. Postulate. You're going to see a lot of postulates this whole first semester. A rule that is accepted without proof. We just accept it. We just use it. We don't have hardcore proof on it. We just use it. A theorem, there is actual proof for it. So that's really the difference. A postulate we just accept. We don't have the hardcore proof on. Theorems we do. That's as wild as that gets. Okay. Bottom thing on here. This is so wordy for something so easy. Let's read it. Let's read it. The points on a line can be matched 1-to-1 with the real numbers. The real number that corresponds to a point is the coordinate of the point. The distance between the points A and B, written as AB, is the absolute value of the difference of the coordinates of A and B. Whew, okay, that's word. I'm going to make it easy for you. Ready? Let's say this is at 2. A is at 2. B is at 10. What's the length of AB? What's your guess? From 2 to 10. 2 to 10. How many units is that? 8. 8's the answer. That's all you have to do is figure out how many units you go from the left to the right. If you want to get fancy, you can subtract it. 10 minus 2 is 8, and the absolute value of 8 is 8. But that seems like a whole lot of extra work. 2 to 10, you cover 8. That's what we're going to do. All right, let's do it. Now, flip it. I know, you're shocked. There's more vocabulary and, of course, more symbols. Okay, so only thing you have to fill in on this, of course, is the highlighted part here. Line segments that have the same length are called congruent segments. You're going to see congruent marks a lot in this class. You can say the length of segment AB is equal to the length of segment CD. You can say segment AB is congruent to segment CD. And you can see this little symbol here, little guy. It's got the squiggly above the equal. That's the congruency symbol. All right, couple things I'm going to point out to you. Mine are in red. Yours are not. Obviously, we don't have color copy machines. These little red tick marks mean congruent. So anytime you see that on a pair of segments, they're the same. Be aware of that. All right, notation. I'm going to start on this congruent side. Notice your congruency symbol, the squiggly. You have to have the segment symbols on it. So I just think all the top symbols go together. If I have the squiggly congruent, I need my segment symbols. If I just have an equal, plain old boring equal sign, notice you don't have the segment symbols on top of AB or on top of CD. Does it matter? Yes. If you have equal, no segment symbols. Congruent, segment symbols. You have to keep them paired together. Only use the segment symbols on congruency, which has the extra little squiggly symbol on top. All right, just for the record. Okay, let's do it. So we're going to plot some points. Plot those points, start plotting them out. We're going to label them. We're going to figure out if these segments are congruent. So let's see. J is at negative 3, 4. So left 3, up 4. Label it. That's a J. K is at 2, 4. Right 2, up 4. L's at 1, 3. And M1, negative 2. So I'm going to give you a second to plot all your points. Nothing like ending the day with geometry. You guys are so lucky. All right. Then determine, is segment JK, draw in segment JK. Here I am constructing segments, title of the section, and LM. Okay. We want to know if they're congruent. So all I'm going to do, I'm going to get crazy here, I'm going to count how many units do I cover from J to K. 1, 2, 3, 4, 5. Okay, so that's 5 long. I'm going to count how many units from L to M. 5. Are, tough question, kids, feel my sarcasm. Are the segments congruent? Yes. Okay, there's our final answer. Now, I'm going to get fancy because I feel like being fancy. I'm going to say JK is congruent to LM. I'm going to go fancy style. Can you just say yes? Sure, you can just say yes. Sure. Just get you they're congruent. All right, you're up. Try this one. Plot them, count them, tell me if they're congruent. I'm just going to start plotting the points here. -2, 4, maybe. Let me just draw in the segments here quick. Let's see, AB and CD. Okay, how long did you get for segment AB, the top one?
5.
Agreed. What did you get for the CD?
4.
Big exciting question, class. Are they congruent?
No.
Or I'm going to get fancy. You know I love the notation. I'm going to say AB is not congruent. I know, fancy, to CD. Just to throw the notation there, just like a not equal sign. All right, I don't think we've done anything too crazy. I think we can all count the length of segments, obviously. Let's get to the good stuff. Okay, segment addition postulate, or affectionately known as SAP. You will use it throughout this whole first semester. It looks very fancy and formal for something I promise you is very, very, very simple. Okay, so first, before we read all of this stuff and get into the craziness, just humor me. I said this was 2, this is 5. What's the length of the whole segment? Whole thing, left all the way to the right. 7. How'd you get it? That's what we're going to do now. Okay, we're going to add the left piece to the right piece to get the whole length of the whole segment. That's what it is. All right, only thing this is telling you at the top, you have to be on a line to use segment addition postulate. I could not use segment addition postulate on this right-hand picture. The points have to be vocabulary time, collinear. We learned that yesterday. They got to be on the same line. Okay, big exciting stuff. So you have to fill this in on the blanks. This is a little more formal. And this is just what you guys were telling me up there. You did 2 plus 5 and got 7. They're just using this. They're doing AB plus BC to get the whole thing A to C. That's how you got 7. Just the fancy formal way to write it out. So fill that in on the blanks. And eventually, not for a little bit, not for a ways, eventually we're going to do some problems and you just have to explain to me what you're doing and how you got the answer, and you'll be using segment addition postulate on a lot of them. Remember, you don't have to write out the whole phrase segment addition postulate. You can just abbreviate it with SAP. All right, let's do some. Now we actually have some numbers. I like it. Use the segment addition postulate. Okay, begin by writing an equation using segment addition postulate, then find the length. Now, I'm 100% confident you can tell me the length of D to F. Don't yell it out, just mental it. From D to F, probably got a number in your head, right? Probably can write it down. That's no big deal. Here's the yuck part, okay? This writing an equation part, which is the same directions on your homework. The first 8. Yeah, I had to mentally picture. 8 problems are going to tell you to do this. So here's what I want for you. This is super easy. So we're just practicing our segment addition postulate. The left segment, so DE plus the right segment equals the length of the entire segment d to f. That's what I mean for an equation. Is it kind of necessary? Probably not, because I guarantee you have an answer. What's the length of df? Tell me. 58. You added them up. 23 plus 35 is 58. Do I really need work to get 58? No, we can add in our heads. But we're practicing our equation. You'll see why. We're going to need it in the next one for sure. So I'm going to do the same thing to kick it off. First, I'm going to write the equation. So the left, FG, plus the right, GH, equals the entire segment F all the way to H. So there's the equation. I know, I'm kind of lame, you have to write it. It'll help you in the next problem. All right, let's answer what they really want from you. What's GH going to need to be? If the left's 21, how much more do you need on the right to get you to the 36? 15. Now, did we really have to do any work to get the 15? No. This equation's probably a little unnecessary, but it's going to help us in the next problem. Okay, so the first 8, I want to say on the homework, are just like this. You're going to have the equation and the answer. You can mental math the answers. This is the same style of problem, but there's no picture, and we got to do a little more algebra. There's not quite as many numbers. So here we go. Point S is between R and T on segment RT. Now, I'm a picture person. I'm going to draw a segment RT. And it says S is in between them. Well, I don't know where S is. I'm just going to slap it on here somewhere. Okay, I'm going to label what they gave us. RS, 3x minus 16. ST, 4x minus 8. And then you've got the whole thing here, RT is 60. Okay, we got it. Use the given info to write an equation in terms of x. So the nice thing is I don't have to do the RS plus ST equals RT. I can skip that. I can just use the expressions with x. So the left side, RS plus ST equals the entire thing of 60. So here's the equation you need for that. Okay, let's solve it. Combine your like terms. What's 3x plus 4x? 7x. What's negative 16 minus 8? Negative 24. All right, let's see your solving equation skills. What's your next move? Add 24. And this is where I said the only thing you might need a calculator for today, but hopefully you know it. That's 84 divided by 7. 12. I'm going to circle that. Now, just when you think, yes, we're done. We're almost done. Read closely. And this you'll see a lot in geometry. Blah, blah, blah. Write an equation in terms of x. Solve the equation. Did it. I need RS and ST. I need the actual numerical values for them. Okay, we can do it. If you put 12 in there for x, let's mental math it. What's 3 times 12? 36. Minus 16. 20. So it's 20. Now, I'm not even going to get too carried away on ST. I can mental math that guy. If the whole darn thing's 60 and we already have 20, what's ST? 40. But we also need those two because it asks for them. So any questions on that? Okay, so